College Trig, Chapter 9, Section 1, Trigonometric Identities. We're going to start with the fundamental identities in this section. We've actually seen most of these already. The new ones that you haven't seen are called the negative number identities, and these relate how the trig functions of opposite angles relate to each other. In other words, how does the sine of an angle like 30 degrees relate to the sine of negative 30 degrees? How does the cosine of 52 degrees relate to the cosine of negative 52 degrees? So we're going to look at those relationships. Now, here, this is really, really important. You need to pay attention to what I'm saying here very carefully. Look at what this says. None, zero, zip, none of the identities in this section, in section 1, are on your formula sheet. None of them. Any identities we discuss in chapter 9, section 1 are your responsibility to know. They are not on your formula sheet. I will not be giving them to you. They must be in your head. Now again, most of these you should already know. And I've told you some of these were coming. Now, once we get past this section, we're going to have a whole lot more identities, and those will be on the formula sheet. But the ones that we encounter in this section are not, and they are your responsibility. Okay, first of all, these should be very familiar. We have our reciprocal identities. You should already know these. The cotangent and the tangent are reciprocals of each other, the secant and cosine, the cosecant and sine. You should know those. You should also know by now that the tangent is the sine over the cosine, and the cotangent is the cosine over the sine. Those should be already a part of your memory. If they're not, you have a little catch-up work to do. You need to get these down. I've warned you about the Pythagorean identities. You need to know these. The first one is utmost critical importance. You must know the first one. Can you get away without knowing the second two? You can, especially if you understand that you get them by dividing the first one either by cosine squared or by sine squared. If you know how to derive them, that's good. Otherwise, you really do need to get them down. Notice that the cotangent, cosecant appear in the same formula here, and having those together can kind of help you remember them. Now here's our negative number identities, and what it says is that the sine of the negative of an angle is the same as the negative sine of that angle. In other words, the sine of negative 52 degrees is the same as the negative of the sine of 52 degrees. And the reason for these, if you look at your unit circle and at the quadrants, that's where these are coming from, really. If you look at the where these angles would be located in the quadrant, the negatives of the different angles. The sine of negative 30 degrees, well, it would be the same as the sine of 30 degrees, only negative. Because it would be, the sine of 30 is in the first quadrant, the sine of negative 30 is in the fourth, the sign there is all negative. So it's just based on where the quadrants are. Notice the cosine. The cosine of the negative of an angle is the same as the cosine of that angle. The cosine of negative 212 degrees is the same as the cosine of positive 212 degrees. Okay, that's true for cosine and secant. Notice all the others have the same relationship as sine. So if you can remember what sine is, and remember what cosine is, and that cosine and secant are different, then you're good there. If you can remember the pattern, sine is like everything works like sine except for cosine and secant. Cosine and secant, the negative cosine negative of an angle is the same as the positive cosine of that angle. But for sine, cosecant, sine, cosecant, tangent, cotangent, it's, the sine of the negative of the angle is negative sine of the angle. Tangent of a negative angle is the negative tangent of the positive. You can get those in your head, but you do need to know these. So we're going to use these identities and express cosine in terms of tangent. This should be very simple. Pause, give it a try, and resume to check your answer. Okay, secant is related to tangent and cosine. So tangent squared of x plus 1 equals secant squared of x. And we just put them in the formulas there. What they did was they said, well, if tangent squared of x plus 1 equals secant squared of x, then 1 over tangent squared of x plus 1 must be equal to 1 over secant squared of x. And then they said, okay, well, secant squared of x is 1 over secant squared of x is cosine squared. And then they basically took the square root of both sides and then rationalized the denominator. Okay. Now, there are other ways you could have done this. This is the way they chose. Write tangent of theta plus cotangent of theta in terms of sine and cosine. Okay, using our identities, give this a try. Pause the recording and resume to check your answer. Okay, so what we did here was we said, well, tangent is sine over cosine and cotangent is cosine over sine. And then what we want to do is mush it together into one fraction. So we give them a common denominator of cosine sine. And then we combine them and we end up with sine squared plus cosine squared in the numerator, which is 1. So we have 1 over cosine theta sine theta. Okay, what we're going to be doing a lot of in this section is what's called verifying identities, and we'll be doing this as we go through in several sections probably, but the first thing you've got to do is learn these fundamental identities. And again, these are not on your formula sheet. These are ones that you need to know. If you don't know them, you are not going to be able to do this. I mean, that's just knocking the foundation right out from under you. You've got to know them first. Once you know them, then what you're going to do is you're going to be rewriting the more complicated side of an equation so it's identical to the simpler side. What we're doing with verifying identities is they will say, show that this expression is the same as this expression, that they're equal. And you're going to do that by using the identities one step at a time and changing one side into the other, changing it to look like the other side. It's best to try to start with the complicated side and work from there towards the simple. It's often helpful to express all functions in terms of sine and cosine. That is really a lot more helpful than you may even realize. That's kind of like if all else fails, try changing everything to sines and cosines. It helps a lot of the time. Usually, any factoring or indicated algebraic operation should be performed. And notice here what we're doing. Sine squared of theta plus 2 sine theta plus 1. That is like x squared plus 2x plus 1. That can be factored. When you've got two fractions that you're adding together, give them a common denominator and combine them. You usually want to do that. As you select substitutions, keep in mind the side you're not changing because that's your goal. See, a lot of times when you're solving a problem, you don't know what the answer is. Here, you know what the goal is. You know what it's supposed to look like. You just need to work your way towards that. And if, let's see, if an expression contains 1 plus sine x, if you multiply the numerator and denominator by 1 minus sine x, gives you 1 minus sine squared of x. Well, Pythagorean identity, if you solve it for cosine squared, you get 1 minus sine squared. So 1 minus sine squared is the cosine squared, and that's a nice trick you can use a lot of the times. All right, so we're going to verify that the following equation is an identity. We're starting with the cotangent of x plus 1, and we want to show that that equals the cosecant of x times the cosine of x plus sine of x. Right off the bat, I am noticing sine and cosine. So I might want to make some changes towards that. All right, looking at this, it looks like the right side is the more complicated side, so that might be the side you want to start with. Pause the recording, give it a try, resume to see how you did. Okay, the right side's more complicated, so we're going to work with it. And guys, there is usually more than one way to do this. Now, usually there is one way that is maybe faster or simpler than the others, but very rarely is there only one path to the solution. So your answer may look slightly different, but you may use completely legitimate means to get there. Okay, so what they did was they multiplied, well, first they changed cosecant to 1 over sine x, and then distributed. So we have cosine x over sine x plus sine x over sine x, which is, well, cosine over sine is cotangent, so we have cotangent of x plus 1. And then off to the side, they've kind of explained it. Now, you don't actually have to do that. You just have to use properties that actually work. You have to use the identities. So we're done. 3 steps. Okay, try this one. Pause the recording, give it a try, and resume to check your answer. Okay, so what we're doing here is we're separating the fraction into 2 parts with the common denominator, and then they're pulling out the tangent. So you've got tangent times 1 over sine cosine minus cotangent times 1 over sine cosine. Then they convert the tangent and the cotangent to sine over cosine and cosine over sine, which allows parts of the fractions to cancel. And you're left with 1 over cosine squared and 1 over sine squared. 1 over cosine squared is secant squared, and 1 over cosine squared is sine squared. All right, this one's a little tricky. What you're going to do is or what they're going to do anyway, is they are actually going to start with the left-hand side and go a certain length with it, and then they're going to take the right-hand side and work with it and try to make a meet in the middle. Okay, so this is just one approach. You don't have to do it this way. Pause your recording, give it a try, and resume to check your answer. So again, we're taking the left side, and they multiply top and bottom by cosine because they noticed, hey, I need to get a cosine in there. And when they distribute, you notice you've got secant times cosine. Well, secant and cosine are reciprocals. When you multiply reciprocals, you get 1. So that leads us to 1 plus tangent cosine over 1 minus tangent cosine. They then changed tangent to sine over cosine, and that's simplified to 1 plus sine over 1 minus sine. Starting with the right-hand side, and they're going to see if they can make it get down to the same thing. So what they did is they factored the top, and we got 1 plus sine alpha squared over cosine squared. Well, cosine squared is the same as 1 minus sine squared if you solve the Pythagorean theorem or Pythagorean identity for cosine squared. And cosine 1 minus sine squared, factors into 1 plus sine times 1 minus sine. And then we can cancel, and that leaves us with 1 plus sine alpha over 1 minus sine alpha, which is what we ended up with when we worked with the left-hand side. So it's kind of like a meeting in the middle for that. All right, let's try an application problem. Read over this, pause the recording, give it a try, and resume to check your answer. Okay, so E of t equals L of t plus C of t, which is putting in the values there, k sine squared of 2 pi of t plus k cosine squared 2 pi of t. Well, factoring out the k, sine squared plus cosine squared is 1, which leaves us with k, which is a constant. Some additional practice problems. Pause the recording, give them a try, and resume to check your answers.